Before computers, before automation, one bulldozer could replace an entire team of men. These machines didn't just push dirt, they carved roads through mountains, cleared forests, and built cities from nothing. No screens, no sensors, just raw horsepower, steel tracks, and operators who trusted iron more than technology. They worked in heat, mud, snow, and war zones. They never complained. They never quit. Many are still running today, decades later. This is the story of 10 old iron bulldozers that outworked an entire crew machines so powerful one was enough to change the land forever. Number 1. Caterpillar D9. Among all bulldozers ever built, the Caterpillar D9 stands in a class of its own. It is not just a machine. It is a standard by which heavy dozers are judged. From massive earth-moving projects to military engineering and mining operations, the D9 earned its reputation by doing what smaller machines simply could not. Where crews once labored for days cutting slopes, pushing rock, or clearing land, a single D9 could accomplish the same work in hours. The reason lies in how the D9 was conceived. It was engineered from the ground up for sustained, brutal workloads. Everything about it, its frame, undercarriage, final drives, and blade mounting, was overbuilt. The machine was not meant for light grading or decorative landscaping. It was designed to live in quarries, mines, and large construction sites where every push mattered. The weight of the machine itself became part of its strength. That mass translated into traction, allowing the blade to bite into dense soil, broken rock, and compacted earth without losing grip. What truly made the D9 outwork a crew was efficiency over time. A crew of laborers might break rock with tools, move material in small loads, and spend hours repositioning. The D9 removed those inefficiencies. It pushed massive volumes in a single pass. Its blade could carry more material than dozens of wheelbarrows. An experienced operator could shape terrain with surgical precision, carving benches, roads, and embankments with speed and consistency. Equally important was durability. Early D9s were built with simplicity in mind. Controls were mechanical, systems were straightforward, and components were accessible. In remote job sites, mechanics could service engines, transmissions, and final drives without specialized electronics. That meant the D9 stayed working while other machines sat idle waiting for parts or technicians. In real-world terms, uptime is productivity, and the D9 excelled at staying alive. The machine also became a platform. With rippers, winches, root rakes, and specialized blades, one D9 could replace several machines and many workers. It could rip bedrock, push spoil, clear forests, and recover stuck equipment. Instead of coordinating multiple crews and machines, a site manager could rely on one D9 and one skilled operator. This is why the D9 became legendary. It didn't just move earth. It collapsed timelines. It turned weeks into days. It embodied the idea that one machine, correctly designed and correctly used, could outwork an entire crew. Number 2. Caterpillar D8. If the D9 represents brute domination, the Caterpillar D8 represents balance. For decades, the D8 sat at the sweet spot between sheer size and practical versatility. It was large enough to perform heavy earth-moving, yet manageable enough to be deployed across a wide variety of jobs. Road construction, quarry benching, dam building, and large site preparation all fell comfortably within its capabilities. The D8 became the dozer contractors trusted when a project required consistency more than spectacle. It was powerful enough to move significant volumes of material, but agile enough to work in tighter areas where a larger machine might struggle. This made it a cornerstone on long-term projects where terrain changed daily and tasks varied by the hour. One of the D8's greatest strengths was its adaptability. It could be configured for pushing, grading, ripping, or slope work. A D8 equipped with a ripper could fracture compacted soil or rock in the morning, then switch roles to spreading and shaping material in the afternoon. That versatility replaced specialized crews and machines. Instead of calling in breakers, loaders, and graders, one D8 could handle the workflow in sequence. The machine's engineering emphasized durability without excess complexity. Components were built to survive vibration, shock, and prolonged load. Cooling systems were robust, allowing continuous operation in hot climates. Controls were direct and predictable, letting operators develop a rhythm that maximized output. On road projects, the D8 often became the backbone of progress. It carved paths through hillsides, built embankments, and established grades long before paving equipment arrived. In quarries, it moved blasted rock efficiently and safely. Compared to manual labor or smaller equipment, the D8 compressed entire phases of work into manageable timeframes. What made the D8 legendary was not raw size, but consistency. Day after day, it delivered dependable performance. It did not need perfect conditions. Mud, dust, heat, or cold did not stop it. In environments where crews would slow, rest, or struggle, the D8 kept pushing. That reliability is why many veterans describe it as a crew in steel. One operator in a D8 could perform the work of dozens of laborers with tools. It didn't replace human skill, it amplified it. The D8 turned experience into productivity at a scale no crew could match. Number 3. Caterpillar D7. The Caterpillar D7 occupies a unique place in bulldozer history because it bridged two worlds, civilian construction and military engineering. It was powerful enough to move large volumes of earth, yet compact enough to be transported, deployed, and maintained in challenging environments. That made it invaluable not only on construction sites, but also in military operations, disaster recovery, and frontier development. The D7 was engineered around torque rather than raw speed. Its engine delivered steady pulling power, ideal for pushing heavy blades or dragging winched loads across uneven terrain. This characteristic made it particularly effective in environments where momentum mattered more than velocity: mud, sand, rubble, and forest floors. In civil construction, the D7 became a workhorse for site preparation, trench support, and embankment building. It could shape land, push spoil, and support excavation crews. On military projects, it cleared obstacles, built fortifications, and opened routes through hostile terrain. In both contexts, its value was the same. It enabled progress where manpower alone would be slow, dangerous, or impossible. What allowed the D7 to outwork crews was endurance. Its mechanical simplicity meant fewer breakdowns. When issues did occur, repairs could be made quickly with basic tools. In remote areas, this was critical. A crew of laborers could only work as long as conditions allowed. The D7 worked as long as fuel was available. Operators often described the D7 as predictable and forgiving. That predictability mattered. When a machine behaves consistently, an experienced operator can work faster, closer to limits, and with less hesitation. Over hours and days, those small efficiencies compound into massive gains. The D7 also demonstrated that size alone does not define productivity. It lacked the sheer mass of larger dozers, yet its balance of power, traction, and maneuverability allowed it to perform a wide range of tasks without delay. In many projects, a D7 could do nearly everything required before larger equipment arrived. In this way, the D7 became the archetype of the do-everything dozer, a machine that could arrive early, work continuously, and prepare the ground for everything that followed. It did not just replace labor, it restructured how projects began. Number 4. International Harvester TD Series. While Caterpillar dominated large industrial sites, International Harvester brought bulldozing power to farms, forests, and frontier landscapes. The TD series, particularly the TD18 and its relatives, emerged from agricultural roots. These machines blended tractor heritage with crawler engineering, producing dozers that were rugged, accessible, and immensely capable in rural settings. The TD series thrived in places where full-scale construction fleets did not exist. Farmers used them to clear land, build ponds, and carve access roads. Loggers relied on them to move timber and prepare forest tracks. Small contractors used them to shape building sites and terraces. In these environments, a TD dozer often represented the only mechanized force available. What made these machines transformative was independence. A single TD could perform tasks that previously required teams of workers with axes, shovels, and animal power. Clearing stumps, leveling fields, and moving soil became mechanized. Projects that once spanned seasons could be finished in days. International Harvester emphasized mechanical simplicity. Engines tolerated inconsistent fuel quality. Systems were robust and accessible, Rural mechanics could keep them running with basic tools and ingenuity. That meant productivity did not depend on external support networks. The TD series became an extension of the landowner. Instead of hiring large crews, operators could work alone. One man and one machine could reshape landscapes. That shift changed how rural development occurred across many regions. These dozers did not dominate headlines, but they changed lives. They turned isolated land into usable property. They replaced labor-intensive traditions with mechanical efficiency. In doing so, they embodied the idea of outworking a crew more literally than perhaps any other machine on this list. Where manpower once defined limits, the TD series erased them. Number 5. Komatsu D65, D85. When Komatsu began challenging Western heavy equipment dominance, it did so not with spectacle, but with consistency. Models like the D65 and D85 did not attempt to be the biggest or loudest bulldozers on the job site. Instead, they focused on something far more valuable: predictable, continuous productivity. These machines earned trust because they worked hour after hour with minimal interruption, even in punishing environments. Komatsu engineers emphasized thermal stability, efficient power delivery, and long component life. Cooling systems were over-designed for heat and dust. Engines were tuned for steady torque rather than short bursts of power. The result was a dozer that could run all day without overheating or fatigue. On long projects, that trait alone made them outperform larger machines that spent time sidelined for maintenance. The D65 became especially popular in mixed earth-moving roadwork, embankment, site leveling, where precision mattered as much as raw push. Its size allowed it to maneuver in spaces too tight for massive iron, yet it had enough blade capacity to move serious volumes. Operators valued how smoothly it responded. Fine control allowed them to shape terrain accurately, reducing rework. The D85, stepping into heavier duty, extended this philosophy into larger-scale work. It retained the same reliability-focused DNA, while offering greater blade capacity and traction. In quarry support and large civil projects, a D85 could rip, push, and spread material continuously. Instead of rotating machines or waiting for specialist equipment, crews relied on one Komatsu to perform multiple roles. What made these machines outwork a crew was not dominance, it was endurance. They rarely demanded attention. A Komatsu dozer on a job meant fewer pauses, fewer emergency repairs, and fewer lost hours. Over weeks and months, those saved hours translated into enormous productivity gains. Komatsu's rise proved that a bulldozer doesn't need to be monstrous to be transformational. Reliability multiplied human effort more effectively than brute force alone. In real-world construction, the machine that never stops often beats the machine that impresses. Number 6. Fiat-Allis FD and FL series. The Fiat-Allis bulldozers emerged from a fusion of Italian engineering and American heavy equipment heritage. These machines were designed for long, grueling work in quarries, mines, and infrastructure projects. They became especially respected in regions where heat, dust, and rough terrain punished lesser designs. Fiat-Allis dozers emphasized structural rigidity. Frames were heavy, undercarriages robust, and drivetrains built for torque rather than speed. These machines were intended to push heavy material continuously, not sprint across sites. In quarry operations, a single Fiat-Allis dozer often served as both ripper and spreader, eliminating the need for multiple machines. Cooling and filtration systems reflected European industrial experience. Dust protection and airflow management allowed the machines to run in harsh environments without constant shutdowns. For operators, this meant fewer interruptions and more predictable output. The FD and FL families were often equipped with heavy rippers, making them effective in breaking compacted rock and hard soil. Instead of calling in blasting crews or specialized breakers, operators could fracture material mechanically and immediately begin spreading it. That workflow compressed entire phases of work into a single machine cycle. What distinguished Fiat-Allis was balance. These dozers did not chase extremes. They combined adequate power with superior stamina. On projects where machines ran 10 or 12 hours daily, that endurance mattered more than peak horsepower. The machine that kept working while others rested effectively replaced both labor and logistics. In many regions, Fiat-Allis dozers became synonymous with reliability. They didn't dominate marketing, they dominated schedules. They were the machines contractors trusted when failure was not an option. Number 7. Allis-Chalmers HD Series. Allis-Chalmers approached bulldozing from an agricultural mindset. The HD series of crawler tractors combined farm tractor heritage with industrial reinforcement, producing machines that were adaptable, durable, and easy to maintain. These dozers thrived in environments where one machine had to serve many purposes. Farmers used them for clearing land and shaping fields. Contractors used them for small construction projects. Their engines were forgiving, their drivetrain straightforward, and their frames strong enough for heavy blades and rippers. The HD machines became known for their ability to work in soft or uneven ground. Wide tracks and favorable weight distribution reduced sinking and slippage. In muddy fields or freshly disturbed soil, these dozers could continue working where others stalled. Their serviceability made them invaluable in rural settings. Parts could be fabricated, repairs could be improvised. A single operator with basic tools could keep the machine productive. In these contexts, the HD series literally replaced crews. Where 10 men might once dig and level, 1 man and 1 dozer now reshaped the land. The HD dozers demonstrated that power is only useful when it's available. Their design philosophy centered on accessibility and resilience. They worked not because they were extraordinary, but because they were always ready. Number 8. Euclid TC-12 Terra Crawler. Long before modern ultra-class mining dozers dominated open pits, Euclid introduced one of the most ambitious crawler tractors ever built, the TC-12 Terra Crawler. Developed in the late 1950s, this machine was not designed for small construction sites or road grading. It was built to reshape landscapes on a scale previously reserved for armies of men and fleets of machines. The TC-12 weighed over 100 tons and was powered by twin diesel engines mounted side by side. Its sheer mass gave it traction that bordered on unstoppable. Where conventional dozers struggled for grip in loose overburden or blasted rock, the Terra Crawler simply pushed forward. Each pass moved volumes of earth that would have required dozens of laborers with carts and shovels. Euclid envisioned the TC-12 as a one-machine earth-moving solution. Instead of coordinating scrapers, loaders, and multiple dozers, a single Terra Crawler could clear, push, and shape massive areas. It was intended for dam projects, strip mining, and large-scale civil works where time equaled money. What made the TC-12 extraordinary was not just its size, but its concept. It embodied the idea that one machine could replace an entire workforce. On sites where hundreds of workers once cut and moved soil manually, the Terra Crawler reduced the operation to one operator and a mechanic. However, its ambition also limited its spread. Transporting such a massive machine was difficult. Maintenance required heavy equipment. Only the largest projects justified its presence. As a result, few were built and fewer survived. Yet those who saw one in action never forgot it. The TC-12 could push spoil banks that swallowed smaller dozers. It could carve terraces into hillsides in a single pass. It worked not with speed, but with inevitability. It advanced, and the ground moved. In its time, the Terra Crawler represented the ultimate expression of old iron philosophy. Replace human labor with mechanical persistence. It did not symbolize efficiency in minutes, it symbolized efficiency in scale. One TC-12 could do what once took entire camps of workers. It remains a monument to an era when engineers believed the answer to labor was mass, steel, and unstoppable force. Number 9. Liebherr PR 764. Early series. When Liebherr entered the crawler dozer market, it brought a distinctly European philosophy. Combined brute strength with mechanical refinement. The early PR 764 embodied that vision. It was not just a bulldozer, it was a mining-grade earth mover designed for continuous industrial-scale work. Unlike many older machines built purely for ruggedness, the PR 764 emphasized balance. Its frame was massively reinforced, yet weight distribution was engineered to maximize traction and minimize ground loss. The result was a dozer that pushed harder per ton than many heavier rivals. In quarries and open-pit mines, the PR-764 became known for relentless productivity. It worked long shifts without overheating. Its driveline tolerated sustained torque loads. Its undercarriage survived abrasive stone environments that destroyed lesser machines. What made the PR-764 outwork a crew was its rhythm. It did not sprint. It advanced steadily, pass after pass, hour after hour. While human crews fatigued, the machine did not. While smaller dozers cycled in and out for maintenance, the Liebherr kept moving. European operators valued its precision. The machine could shape benches and slopes with remarkable accuracy for its size. This reduced the need for rework. Instead of crews correcting grades by hand, the dozer delivered near-finished surfaces directly. The PR-764 represented a new generation of old iron machines that combined raw strength with intelligent engineering. It proved that bulldozers did not need to be crude to be powerful. They could be both refined and relentless. In mining environments where delays cost millions, the PR-764 earned trust. It replaced not just labor, but coordination. Instead of managing teams to correct errors or compensate for downtime, managers relied on the machine's consistency. It stood as Europe's answer to American heavy iron, a bulldozer built not merely to move earth, but to dominate time. Number 10. John Deere 850. Early models. Before the 850 series, John Deere was primarily associated with agriculture. The introduction of the 850 crawler marked a turning point. It brought true industrial bulldozing capability into the hands of small contractors, farmers, and land developers. The early 850 combined a powerful diesel engine with a robust undercarriage and a blade large enough to handle serious earth-moving. It was not a mine dozer. It was something more revolutionary, a machine that allowed one person to perform work once reserved for large crews. Land clearing, pond building, road cutting, and site preparation became individual tasks. A single operator could reshape acres. What once required hired labor, animals, and weeks of effort could be done in days. The 850 earned a reputation for reliability. Its components were straightforward. Its systems were accessible. It tolerated rough use and infrequent maintenance, critical traits for owners operating far from dealers. What made it transformative was accessibility. Big iron belonged to corporations. The 850 belonged to individuals. It democratized bulldozing power. Farmers used it to terrace fields and build reservoirs. Small contractors used it to compete with larger firms. Homesteaders carved roads into wilderness. In each case, the machine replaced manpower with mechanical persistence. The 850 did not dominate through size. It dominated through empowerment. It turned one person into a workforce. In the context of old iron that outworked a crew, the 850's impact was perhaps the most personal. It didn't replace labor camps. It replaced the need for them. It proved that progress did not always come from giants. Sometimes it came from giving ordinary people extraordinary tools. So that's it for today. If you like this video, then please hit the like and subscribe button for more videos. Thanks for watching.